Let me share my screen. So you're seeing my screen now, right? Okay. All right, so today we'll look at another tutorial question. So if you can see from the screen here, we have a frame here. So these two frames are given a certain distance and height here. So we have a three element here. So element 1 like this, element 2 like this, and element 3 like this. And the axis of y and x is given. Y and x at point 1, and the x prime is given. X prime, the direction is given. All right. And there's a external force at the middle of the beam here, 50 kilonewton, from the top here, from 20 meter from the point number 4. And the total height of this structure is 40 meter. The horizontal distance is 40 or 20, 20, and 30, right? And the modulus Young is given, area is given, and the second moment of area is given. All right, so we have this kind of question, and then we have a frame here. We need to use what we learned in this lecture, in this module, to find all the displacement and rotation and the forces in each element here. Okay, so in this case, we can see that the point 1 and point 2 are fixed, and point 3 also fixed. So let's see how we solve this question, this kind of question. So because we have a force that going in the x direction, the first step is that we need to transform the forces on the element here. We need to transform this 15K so that this 15K will follow the element axis. Right? We just expand this matrix. We change 15K into the direction of the normal direction to the y prime, and then one direction to the x prime here. All right, so these are the first steps, recommended steps. So the first, we just look at the apply load on element 1. So what we have, if we enlarge the element 1 forces, and we draw the element axis, y prime and x prime, if you just export what you see from the screen here, the element 1. So you will see that x prime is going this direction, y prime is going this direction. And you have 15K here, 15 kilonewton at this point, but this point is in the x direction. We need to change this direction, this 15K in this element direction. Okay, this is the first steps for this tutorial question. Right, the next one, then we will find the equivalent joint force at point 1 and point 2, referring to after we convert this one into the middle of the height here, then we will use appendix D to transform this one to both ends. We will put this force. Yes.
I'm not understanding the conversion of element 1 to
okay. Right. So what we need to do for the first step of this kind of question, we need to transform. Okay. This is element 1, right? So you have 1 forces in this direction, 15 kilonewton. You need to, let me change the color. You need to change this. Let me use purple color. So you need to change this one. This 15K, you need to change according to this axis. You need to flip this, or you need to expand this one. You know that you can change this 15K into 2 direction, right? Can you see the one that I highlight just now on the screen here? You can expand this vector into 2 components. Do you understand? Katana, you don't understand what I'm trying to See? We are transforming the 15K direction into the purple color direction.
Yes.
So that's why you see the equivalent diagram that you see on the screen now. So on the left hand side here is actually this component. This one is this one. And then in the beam, we know that the x direction force doesn't create anything to our system. So you see there's a small arrow here. This small arrow is this one, the x, the x prime direction. You understand now? Katana, are you able to understand? Or
Yes, then how about the lower part?
this one? You mean this one? Or next slides? Can you repeat your question again?
The lower part. I've understood the upper part. Now the lower part.
You mean this one, y prime, x prime?
Right. Yes.
This one. So this actually is the element axis. If you look at the diagram here, you're given the element orientation, right? This one, the element orientation. So each element have its own x-axis. So if you label something prime, means we go look at the element itself. So this is the element x-axis. So this is x-axis. You know that all the axes between y and x is always 90 degree, correct? Y and x.
Oh, I see. I understand
Yeah.
now.
So you have two kind of axes. One is the global axis, one is the element axis, x prime and y prime. So when you write prime, it means that you look at the element. Do you get it?
Yes, now I get it.
Okay. Lai, you okay? Lai, are you all right?
Okay.
Okay. Okay, let's move forward. So after you convert the forces, this 15 kilonewton forces into the element dimension, which means you expand the 15K into 2 vector and then you put back in element 1. You redraw the free body diagram and you put back the axis for the element. All right, let's see the next slides. So after that, you convert these forces, because this is forces at the middle. And if you're looking at the appendix D, there's one cases that we can convert this into this one, these forces, this one. We can convert that into this one and this one, and maybe there's some moment at the side. It can convert these forces to force at point 1 and the other end, and a moment by using appendix D. Appendix D. Okay. All right. So after you convert the forces in appendix D, like what you see on the screen here, right? You guys know how to use appendix D already, right? Katana and Lai? You understand the concept behind this one? Why suddenly you're seeing two forces and the moment at both ends? Do you understand?
No.
Katana, you don't understand.
No.
Okay, Lai, you understand? Okay, let's go to the appendix D. So if you already download appendix D, you go to Moodle, appendix D, nodal forces. So we're having case number, having case number 1 here. Are we seeing this one? Are you trying to understand? We convert this one into this diagram. We change the center focus load into two equivalent forces and a moment in this diagram. Do you see this one? Katana, do you understand what we're trying to do?
Yes.
Yeah, Lai, do you understand now?
Yes.
Okay, so back to our slides here. So just now,
Oh yes,
what we
like
have
in
is this
chapter
one.
4, right?
Again, your question? Again, your question? We are transforming this diagram, the one that you see on the screen here, by referring to Appendix D. It actually is a case number 1. So case number 1, we convert this one into this diagram. Do you see you try to relate what is Appendix D and the situation we have here? Are you able to relate Appendix D and this question?
Yes.
Confirm, if you're not sure, let me know. Katana, you sure or not? You sure you understand?
Yes. So for this one end is P over 2, and for this other end 2 is P over 2, right? Is it?
Yeah, you refer to Appendix D. You see this one? Minus P divided by 2. Moment is minus PL divided by 8. This one is at the right left hand side. This one. This one equal to this one. I mean this one you change to both sides lah. Then on the right hand side you use this formula, force and moment. Do you see it now?
Can.
Understand? Understand?
Yes.
Okay. Go back to our PowerPoint slides. So we transform these forces from one orientation to another orientation. One is the application situation. Then we change it into element dimension. We change this one to element dimension. We break this vector, 15 kilonewton vector, into 2 element vector. Okay, this one. Then after that, we refer to Appendix D. We change this diagram into equivalent diagram that you see from Appendix D. You change this focus load here into 2 forces at the end and with the moment. Okay, with the moment. So the magnitude of all the formula here you refer to Appendix D. It depends on the cases you have. Yeah. So Appendix D, again, just to recap, Appendix D you have 9 cases here. So you have the first cases within the middle, second cases where you have A and B, where more likely will come out in the final exam. So you have the different ratio, different length of the P is at the position of the different length. So you need to use the second scenario from Appendix D to solve your final exam question, right? So, and then you look at this Appendix D and then you compare to the situation you have, and then you convert the forces, either it's distributed load or focus load, you transfer or you transform the situation into the diagram on the top here, right? Okay, let's continue with our lecture. So the second, after you convert the forces, all the forces here we will know as equivalent joint force with this F0. All right. So after you convert from Appendix D, all the parameter, the parameter we mentioned from Appendix D means we extract from Appendix D the both end here, the forces and the moment. All these parameter that we convert from Appendix D, we call them as F0, F sub 0, or equivalent joint force. Clear? Clear? All right. Then we go to step number 3. So after we convert all the equivalent forces, then step number 3, we will transform to the joint forces in the global dimension. So we use this equation, F without the, if you see the F without the prime, F prime means this one is at the element dimension. This one without the prime is at the global dimension. Again, we remind yourself that you have two types of axes here. One is y prime, x prime, which is on the element itself. If you without the prime, it means you're referring to the global dimension. Okay, so you need to use this F equal to transformation matrix, T matrix that we already cover, T matrix T transpose times the F prime. So I already show you how to use the online matrix calculator. You can do transpose over there. So it will fasten up your calculation after you learn the skill this morning. Okay, so you can speed up in your calculation later on. Yeah, so you have more than sufficient time for your coming test 2 and also your final exam, since you are given the tools to use already. Okay, so this is what we get in step number 2, or the F0 just now. All right, so we will transform what we have from appendix D. We'll transform them into the global dimension. Means we change all these forces in the global dimension. So on the left hand side is all the forces in the X and Y dimension, or if I draw on the element itself, you will see that this one, all the F and moment on the element itself is on the X prime and Y prime dimension or axis. You need to change all this into global, or we call it global coordinate system with this Y and X axis with this one. How you convert? You use this formula. F equal to T transpose times the F prime, meaning all these forces over here is all your F prime, all your F prime parameter. So how you convert into F prime, or how you convert into all the forces here, you use this formula. F equal to T transpose and F prime. Step number 4, you will analyze as usual. You find all the unknown inside the equation. All right. Then after that, you find the internal forces like normal, like what we do, and then you draw the free body diagram. So how do we find the final internal forces? We use this formula. F equal to F element minus F0. So after we find in step number 4, we find the element forces. We minus the one that we get from appendix D. The forces we extract from appendix D, then we get the internal forces. Yeah, we will go through in detail now. So let's do it in the more detail. So if you look at this example, so we look at element 1. So before you solve question, you need to know the angle. So how you find the angle? The angle is here. Oh, let me change the color of my pen. So the angle for element 1 is this theta. And the angle we always measure x to x prime, anti-clockwise direction. All right. So if you want to find the angle here, Katana, are you able to explain how you find the angle here with all the dimension you have on the screen here? Are you able to explain?
Yeah, we can use trigonometry.
Yeah, so for example, in this case, you want to find the angle for element 1. How you find it?
That would be just a minute. I find it.
You are using what? Sine, cos, or tangent?
Right. I use sine.
Sine theta equal to what times what divided by what? You have all the dimension there.
If sorry, wait.
Why you use sine? Yeah, you can use sine, but sine is more complex.
Yeah. I can use a tan.
Yeah,
Theta.
tangent theta equal to what divided by what? You have all the number there. Can you give me number?
40 meters out of 20 meters.
Correct.
4 or 2.
All right, correct. Then you from your calculator you can find the angle. Lai, you able to understand what Katana trying to say?
Yes.
All right. So if you use a tangent or you can use cos or something, the angle will be 63.43. So again, this is a triangular. You have 20, you have 40, you're able to find the length of this one, right? It's also trigonometry chapter, right? It's a square root of this one, square root of square of this one plus square of this one. All right, you're able to find this one. Huh? All right, so let's continue. After you find the angle, the first step for this kind of question, the first step is to find the angle. So there are some marks for to find the angle. So the angle is 63.43 for this example. Then you calculate the cos and sine value like the normal one, like what we covered in the previous example. So you find the cos and sine value. Then after that, you find the constant that you need for the calculation. Right, recall back the 5 matrices that I asked you to, the 5 marks, free marks, the 5 free marks equation they asked you to memorize and not memorize, to put in your answer. You still remember, Katana and Lai? Do you still remember the 5 important equation that I asked you to put in? You still remember? Do you still remember?
Little bit.
Oh, forget already. Okay, just recap. The 5 important equation. 5 important equation. T, okay, the first one, the
Yes.
T, the 3 matrix. Second one, your K matrix, not K matrix, the K prime matrix, this one. The first one is T, the second one is K prime. And of course, K prime, it can be big one. K prime, this one. Remember this one. K prime, where you have a C1 and C2. K prime equal to this one, C1 and C2. C1 equal to AE divided by L, C2 equal to EIL cube. The next equation, the transpose, the T just now. And then, okay, this one, T, K prime, and then this one, this equation. K equal to T transpose K prime T. Okay, this is the third equation.
Yes.
So first equation, second equation, third equation, and then of course the C1, C2, including the C1, C2. And then the fourth one, this one, the big rigid plane frame stiffness matrix. This one, you write in the answer sheet, you get the 5 marks there. Okay, so these are the 5 important 5 marks there. So 1, 2, 3, 4, and C1 and C2. This one, these two. Okay, memorize, or not memorize. Cannot use the word memorize. Remember these 5 matrices equation. When it comes to frame analysis, write all these 5 in your answer sheet there. Straight away, you get 5 marks for this 5 equation. Without starting to solve, you write these 5 equation on the answer sheet, you get the 5 marks. And then the rest, you just keep applying these 5. Yeah. All right. Let's back to our tutorial question for today. The next one is just the first step, find the answer. Second one, find the cos and sine. Find the constant equation, the 12i L square 6i divided by L E divided by L, because this one is one of all the parameter that you need to fill in the 5 equation that I asked you to put in the answer sheet. Okay, makes sense? Everything makes sense to you now? Why you need to calculate the cost, yes. Why you need to calculate the sign and the the unknown here, the 12i L square, 6i L, EI L, so on. You substitute all the value. And then recall again the one of the 5 equation that asks you to put in the answer sheet, the K stiffness matrix. And this one is for the rigid frame analysis. The AC square plus 12i L square S square and so on. Okay, so this side is symmetry, so you just flip all the numbers that you calculate on this side, flip to this side, and you calculate the EL. All right. And then after that, you look at the boundary condition. Point 1 is mount to the floor there, so there's no movement. So you can close the matrix already. Just close it. You can use pencil to close it. All right. So element 1, you don't have U, V, and rotation 1. So you just close it with your pencil or with your line, draw with the pencil. You only left out with the U4, point number 4 displacement. U4, V4, and rotation number 4. Okay, so this is for element 1. You repeat the same. Okay, so again, you need to know what you need to be careful when you calculate is that for when you write the stiffness matrix for rigid frame, you need to know the point for the element. So for example, if you do look at element 1, the element 1 is connecting point 1 and point 4. So the first 3 column is point 1, the last 3 column is for point number 4. So this is what you need to be careful, because these are the parking sign or parking lot for you to park your number. Because later you need to superimpose them into a very big matrix later. Okay, so for K1, element 1, you only left out the 3 times 3 matrix with this point number 4 value, U4, V4, and angle number 4. Okay, so this is your homework to find the value. But only what is important, you understand the concept. Then you repeat the same for element number 3 here. You look at element number 3. So first step is just to find the angle. So are you able to understand if I say the angle of element number 3 is 0? Are you able to understand why the angle is 0? Yeah, you measure from x to x prime. So this axis x to x prime is 0. Yeah, meaning you put the axis back to here. You take the axis x and y. So x to x prime is 0. And you look at the arrow of your element there. So it's 0. Okay. You repeat the same process. There's nothing complex here. You just repeat the same concept. Once you find the angle, you find all the unknown you need for that 5 equation that I asked you to put in your answer sheet. You calculate the cosine, 12i divided by L square, 6i divided by L, and EI divided by L. You put back in the K matrix that I asked you to put in the answer sheet. But remember, when you write in your answer, remember to have a clear mark above the K there. So for example, if you look at element 3, remember to put K superscript 3 above the K there. Just to tell the examiner that you are actually explaining element 3. Then you put in all the value there. Once you put in all the value, then only you can close. After you calculate all this value inside this matrix, then you look at the scenario you have in the question. Point number 3, not able to move. So all the U, V, and rotation at 3, you can close it with the pencil. With the line, you close with the line. And then you only left out with the U4, V4, and rotation 4, 3 times 3 matrix here. Okay, it's your homework to find all the value here. So element 3 is U4, V4, and rotation 4. Then you look at element number 2, the same process. Element number 2 angle is 116.57, which is here. This is the angle. Oh, sorry. The angle is from here to here, x to x prime. Right. This is the theta for number 3. So angle is 116.57. So you find, again, you find the cos, you find the sine, you find the 12L divided by L square, 6IL, find the EI. Then you put back in the K matrix that I asked you to put in the answer sheet. So again, remember on the note that you have on element 2, you look at the arrow is from point 2 to point 4. So the first 3 column is point number 2. So U2, V2, rotation 2 for the first 3 column. And point number 4 is the last point. So last 3 column is referring point number 4. So if you look at the question itself, the diagram itself, point number 2 is fixed on the floor itself. So there's no movement that can be done by point number 2. So again, use your pencil to close it, to draw a line to close it, and then you only have 3 times 3 matrix. So basically you have 3 matrix there. Yeah. You have 3 matrix, then you combine, you superimpose them into a big one, which is a K matrix here. Then after that, you write this equation, F equal to KD. F equal to KD. After you superimpose all the K matrix together, after you combine all the K together, element 1 plus element 2 plus element 3. You put them together. Okay. So you'll get one matrix, very big matrix. Then after that, you use this equation, F equal to KD. Remember, when you look at the element, you use a small k for all the element. Then you combine 1, 2, 3, element 1, 2, 3. It will become a capital K. Yeah? It will become a capital K after you combine all the matrix together in the big matrix here. This is a combination of all the K, combination of all the small k. All right, let's continue. Then you write F equal to KD. So because the K here is only left out point number 4, so you have U4, V4, rotation 4 inside the K just now. After you combine all the element stiffness matrix in one matrix, then you write F equal to KD, and this is a capital F, so F4X, Fy, 4Y, M4. How you know this is X direction? You refer to the displacement over here. So you have U4, U is in the X direction, so F4X. V is in the Y direction, so second number here is F4Y. Rotation 4, rotation means moment, so moment number 4. So this is how you convert the information. All right. So we know that if you look at point number 4 here, there's no forces going up. There's no forces going up, so F4Y will be 0. Yeah, F4Y will be 0. Or you can straight away go and find the displacement. So yeah, you can solve the 3 equation. Then you're able to find the displacement at point number 4. So this is your homework. Yeah. Then call back the 5 equation I asked you to write on the answer sheet. The T, the D, the D is the displacement that you have. So when you want to find the X prime, F prime equal to K prime TD. If you want to find the element, use this equation. F prime equal to K prime TD. So how I ask you to remember the metric, the 5 matrices now. And then I also show you the way to use the online matrix calculator. So you key in the T value, you key in the D value, and then you press the products of A matrix times B matrix. Then below there, below the website, you have the products of T times D. Then you import into matrix A again. Then you key in the K prime value, the K prime matrix that you calculate from the 5 equation. Yeah. Then you press the multiplication products. You're able to find the answer. Okay. So this is basically all the mathematical steps. So all the value you find in these steps is the element forces, where Fe equal to F1x, F1y, M1, and point number 4 for element 1, F4y prime, and M number 4. It is here. Okay. So these are the forces that you find. All right, I make a remark on the screen here so that you understand what is all this value you find for the element number 4, element number 1. So you have F1. Be careful on this. This is on the axis especially. So this is x prime. Yeah, x prime is along the element itself, x prime. Yeah, and so on. You do the same for other 2 elements. You repeat the same for other element. So element 1. All right, element 1. Once you find the forces for element 1, yeah, you want to find the forces that you have. So what you do, you take the element forces that you find just now, the 6 number, Fe, you minus the one that you find from the appendix D, all the displacement you have. All right, the F0. Then you have able to find the forces for element 1. Okay, so this is basically what is. Then after that, you can draw the equivalent free body diagram. This is the answer that you should have. You take your calculation minus appendix D, you get the forces for element 1. Okay. These are the example for this tutorial question. You repeat the same for element 3 and 2 and 3. Yeah. So again, there's a reminder that I put on these slides. Practice on this type of question. Be familiar with the steps. So, and then you need to know how to draw the free body diagram. These are the sample answer for element 1, element 2, and element 3. After you did the homework calculation for element 1, 2, and 3. All right. So go ahead and practice on this question. All right. I think we stop at this question. You go through the other PowerPoint slides. Yeah, you go through all these PowerPoint slides that I will upload in the Moodle. Then you study. We'll go through the same steps, the same step like before. Look at the step that I show in my PowerPoint slides. Come and see me if you're not able to understand what is or how to find all this value. Yeah. Okay, so this is the additional exercise for this chapter. Okay. So with this, I end the recording.